So this is the part 2 of a review of lecture 19, determinants and cofactors formula. So let's get on with the second one, which is the cofactor formula. I already have my 3x3 matrix here, and I already also expand them as you see in the previous video. So let's see this term closely. So actually we can expand this one. We can factor out the a11 and then do that parenthesis inside. So let's try to do that. And the same goes for actually this one and this one term. So I'll just write them down real quick. So here they are. So I pull out the a11, I pull out the a12, and I also pull out the a13, and I get this term inside. So what are they actually? What is this here? So let's look back in this matrix and look at them closely. So actually this term are that little matrix inside this one. So you remember that if we have the a11 here, then we don't allow any kind of component to be along the row and the column, and we get this little matrix here, which is the leftover of what we are not allowing here. So we are looking for the determinant here, so that's why we got this term a22 minus a3 minus this one. And the same goes for the a12 and a13 as well. Let's see, in a12 we have this term right here, a21, a23, a31, a33. But now remember that we have a minus here due to the determinant of the permutation, so that's why the term got reversed. So instead of a21, a33, we have this term in the negative sign here, and this one have the positive sign because negative minus negative equal to positive. So I hope you have the idea. So let me delete that. And let me just also say that this also works in terms of columns. So we have been working so far with only looking at the rows. So we look at a11 and then we look at the matrix inside this one, or next one we move to the a12 and then we look at only this matrix, and the next one we look at a13 and then we look at this matrix only, which is right here. But this can also work if you want to go along the column. So for example, you can start here a11 and then you look at this matrix. You can start here next a21 and then look at this matrix, or you can start a31 and then you look at this matrix. So it's actually pretty useful to look at the determinant. Like the useful case is when you have the matrix with like a really crowded rows, for example, but then this one has many zeros in it, like 3, 6 or something. For example, yeah, like that. I don't know, let's forget the fact that it will be dependent or independent, but I just want to state the fact that rather than go along the row and you have many factor to multiply there, you can always choose to go along the column because there will be 0 there, and automatically you only have one term and you only need to multiply this and look for the determinant of this. So that's the idea. And the next idea is that this is where it's really clear that you can actually have the determinant of n by n by utilizing the determinant of n minus 1. So that's exactly what you have here. So you have the determinant of n of 3 let's say that n is 3 is 3 by 3 by doing the determinant of n of 2, which is the smaller one. And then there's some use cases in the example where you can go recursively. So for example, you have a really big 4 by 4, and if you look at like this, and then you need to compute this term, and with the smaller one, the n minus 1, 3 by 3, and then you can also go a little bit smaller. You can pick like, for example, the smaller term here, and then you look at the 2 by 2 case, and so on and so forth. There's an example in the book that works on this, so you can work recursively until you arrive at the determinant of 1 by 1, which is just the number itself. So just want to mention that here. And one last thing is that there's this kind of pattern that if you were in the high school or maybe in the calculus, you see where that pattern comes from. So for example, is the plus minus plus minus plus minus. It's like a checkerboard. So again, we work on this before in the big formula. You remember the determinant of p kind of decide like how it goes, whether the sign have plus or negative. So that's how it goes if we decide to take this cofactor formula, and this is just a shortcut to see whether that term has the minus or plus in it. And it also goes into the 4 by 4, so I'll just expand it here like this, and then just remember this pattern. So if let's say here, if you want to go along the column, then the first one has the positive sign and then the determinant of this, and then the second one you have the negative sign first on this term, and then the determinant of the rest of them like this. And yeah, I hope you have the idea. So I'll just write down the big formula, the general formula, which is like this. So the determinant of the A is the A, let me write I for row, CI1 plus AI2 plus CI2 until you get into the I of n into, and then the cofactor of 1 in. And this also goes into the column, as I said. So for column you have 1 of j, c1j, a2j, c2j, and until you arrive at the nj, c and j. And what is C? C here is the cofactor. And the name cofactor comes from the word like co, which is to go along with. So for example here, to go along this term, and to what factor is that the determinant of this smaller matrix. So that's the term cofactor. And the cofactor itself is, we have that so this is the term that governs whether you have the positive or negative sign in that particular term. So remember that the checkerboard we tell earlier. So if in the I1 J1 you have the positive, but in the I1 J2, so minus I to the power of 3, this will be the negative 1, and so on and so forth. I'm sorry, this should be minus. Yep, that's it. So these are the formula. Let me clear up something. So these are the formula that you want to remember for the second part here. So thank you.